Chapter 6.2, Parallelograms. A parallelogram is defined as a four-sided figure where the opposite sides are parallel. You can't say that all four sides are parallel to each other because that just doesn't make sense. Now, if we have a parallelogram, then we know the following things. We know that the opposite sides are congruent. We know that the opposite angles are congruent. We also know that since the sides are parallel, we know that the consecutive angles, or the same side interior angles, are supplementary. And finally, we also know that if a parallelogram has one right angle, then all the angles are right. So we know that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive interior angles are supplementary, and if you have one right angle, all the angles are right. So in this next picture, they're telling us the measure of angle B is 32 degrees. They tell us that the length of CD is 80 inches and that BC is 15 inches. They asked us to find AD. Since this symbol here means a parallelogram, we know that opposite sides are congruent. So the length of AD would be the same as BC, which is 15 inches. Find the measure of angle C. Well, B and C are consecutive angles, so they're supplementary, so they have to add to be 180. So if I did 180 minus 32, that would give me 148 degrees. If I want to find the measure of angle D, I know that opposite angles are congruent, so the measure of angle D would be the same as measure of angle B, which would be 32 degrees. In the next problem, we're asked to find the length of AB. Well, this is a parallelogram, so AB has to be congruent to CD. So AB would be 30. We want to find the measure of angle C, which is opposite the measure of angle A, so it would be 36 degrees. We want to find the measure of angle D. Well, D and A are same side interior angles, so I do 180 minus 36, and I would have 144. In a parallelogram, the diagonals bisect each other. So they cut each other in half. It doesn't necessarily mean that they're congruent. So in the picture, AP would be congruent to PC because BD would bisect it, and AC would bisect BD, so PD would be congruent to BP. We also know that if it's a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. So they're telling us this figure is a parallelogram, and we want to find the value of R. So we need to locate R on the diagram. We have 4R right here. So 4R is the length of the side WX, which is congruent to the side ZY. So 4R equals 18, and R would equal 4.5. In the next problem, we want to find the value of S. S is included in this diagonal here. We know that the diagonals bisect each other, so we know that 8S would equal 7S plus 3. So S would equal 3. Now we want to find the value of T. T is right here, which we know by alternate interior angles would be congruent to 18. So 2T equals 18, and T would equal 9. We want to find the value of X. X is involved in this diagonal here, so 6X plus 2 equals 4X plus 12. So 2X equals 10, so X would equal 5. Two P equals 22, so P would equal 11. Three K plus 4 is part of this angle here. We know by alternate interior angles it has to be congruent to this one. So 3K plus 4 equals 25. So the next one is asking for the coordinates of the intersection of the diagonals of the parallelogram. You do not need to graph this. We just know that M, N, P, R, however they're graphed, have to go in this order here. It has to go in order this way. It's M, N, and as you continue around the clock, it's P, R. We want to find this intersection point, so what we want to find is a midpoint of either MP or NR. So let's find the midpoint of NP. So MP, I need to find the midpoint of it. Using the midpoint formula, it'd be -3 plus 5, so the x's averaged, and 0 plus 4 for the y's. So the midpoint would be 2 over 2, 4 over 2, and our answer would be 1, 2. Again, we can find the midpoint of either MP or NR. So what are the coordinates of the intersection, the diagonals of the parallelogram, L, M, N, O? So we can either find the midpoint of LN or the midpoint of MO. So let's find the midpoint of MO, which will be the same. These are both the same. So MO would be -2 plus 3 divided by 2, 1 plus 1 divided by 2, which would give us 1/2 and 1. Last problem is a proof. And in a proof, we want to prove, in this one, we want to prove that the two diagonals bisect each other. We know, but we actually want to prove it. So the first part of your proof is always the given. So we're given that A, B, C, D is a parallelogram. And that's our given. So I'm going to start with that AB is parallel, so AB is parallel to DC. And that's by definition of parallelogram. Now I know since these two are parallel to each other that this angle is parallel to this angle. I mean, this angle is congruent to that angle. So angle BAC is congruent to angle DCA. And that's because parallel lines give us alternate interior angles congruent. Since it's a parallelogram, I know that side AB is congruent to side DC. Parallelogram gives opposite sides congruent. And then I also know that this angle is congruent to this angle here. So angle ABD is congruent to angle CDB. So now I've proven that triangle ABD APB is congruent to triangle CPD. And that is by angle side angle. Because of that, I can now say that BP is congruent to DP and AP, so BP is congruent to PD and AP is congruent to PC. And that's by CPCTC. And now by definition of bisect, I can say that AC and BD bisect. And that's by definition. And that concludes our lesson for 6.2.